Hi, in this question, we shall see find the direction cosine of 3i minus 4j plus 12k. So, direction cosine basically DC is basically on three axes. On the x axis, it is known as L is equal to cos alpha, that is equal to x by length of the vector. We call this vector as a vector. Suppose we call this vector as a vector, length of a vector, and m or cos beta, that is given by y coordinate divided by the length of a vector, and n is equal to cos gamma, that is z coordinate divided by length of a vector. Actually, it has to be plus or minus, plus or minus. So first we'll find the length of this vector. Length of a vector. See, this symbol basically in the textbook is called as magnitude, or we can call it as length. It's also given in your textbook. We can call this as length. Length is more suitable because you will get confused if you keep on saying, don't say modulus. If you say modulus, then it's not appropriate. You can say magnitude or you can say length. So length of a vector is root of x square plus y square plus z square, that is equal to root of 3 square plus 4 square plus 12 square, that is root of 9 plus 16 plus 144, that is root 169, that is 13. So length of a vector is 13. So L is equal to cos alpha is equal to L. L is x coordinate by length of a vector, which is basically 3 plus or minus 3 divided by length of a vector. So L is equal to 3 by 13, and cos beta is m. M is plus or minus y coordinate by length of a vector, that is minus 4 by 13. So m is minus 4 by 13, and cos gamma is n, that equals plus or minus z coordinate by length of a vector. So that will be n is equal to 12 divided by 13. So these are the direction questions. Direction questions. Now this much is enough for you to solve. But if you want to understand how this direction cosine will look in a 3D geometry, what we'll do is we'll find the cos alpha value of 3 by 13. Cos alpha value of 3 by 13 will come something close to like 3 by 13. When you divide, it will become cos alpha is equal to 0.2307. So alpha is cos inverse of 0.2307. You get an angle which is 76.66 degrees. Cos beta is minus 4 by 13. When we solve this, you will get 0.3077. So beta will be cos inverse of 0.3077, which will be 72.08 degrees. Cos gamma is 12 by 13, that is equal to 0.9231, and cos inverse of 0.9231 is equal to 22.62 degrees. Okay, now we'll check this in 3D geometry. Okay, here in this three dimensional geometry, I have the same vector plotted. Okay, it starts from origin and goes until the point 3i minus 4j plus 12. So this is the actual, in reality, this is what the vector will look in three-dimensional way. So direction cosine is this particular angle, this angle which it makes with the x-axis, y-axis and z-axis. So x-axis is over. Let me center this picture. Okay, now so you are finding direction cosine. That's the angle which you are finding. That angle, if you find, it'll from x-axis what it makes with the vector makes with the x-axis. So let's input those values. So when I input those values, I get 76.66 degrees. So this is the actual value. This is what is cosine angle in, that is L. L is equal to cos alpha. This is what you say is cos alpha. Okay, this is x-axis, from x-axis to the origin until this vector, whatever is the angle is being made. That is what, that only is cos alpha. Now let's see cos beta. Cos beta is along the y-axis. So this is the y-axis. From y-axis, what this angle makes with this vector, what the vector makes an angle with this y-axis, that is what is the cos beta, that is 72.08. And then you have same on the same way you have this z-axis. So these three angles are the cosine angles, and whatever be the vector, this value will not change. Suppose if the vector uh, gets extended. Suppose you extend this vector up to infinity. Wherever it goes, that cos alpha, beta, gamma will never change. These cosine angles will never change. And here you having different values at different section. These are called the direction ratios. These values are the direction ratios. And direction cosine is only one fixed angle, unique angle for one particular vector, and that will remain same. And direction ratios are the coordinates which you get at different sections of this particular vector when you extend the vector or when you shrink the vector, whichever way it is. Okay, hope you will understand this. Thanks.